I'm actually sitting down. Wow, this is what it's like. Welcome back to another one today. Little different than my usual working on an Impala, Hubbard, Angus, And today we're going to be talking about wiring. Wiring is one of those components where you hear wiring and you're like, I don't really know what to do. So if you understand the basics of it, it'll get you by. You'll be more than good enough. So in today's video, I'm going to go over basic circuits. We're going to go over how to use a multimeter. I know I've explained it before, but you guys have seen me use it multiple times. Importance of certain safety features of wiring, i.e. fuses, and how to make proper connections and go over some stuff. So let's get into that. Okay? Okay. So to understand electricity, there's just kind of two types. You got AC, which stands for alternating current, and you have DC, that stands for direct current. Those are the two types we're going to be talking about today. One of them, we're going to get out of here. We're only going to be focusing on direct current. The other thing we got to talk about, amps and watts. Why? Because those are measurements of electricity as well. So you have the two types, AC, DC, which you've all heard that before, not the rock band.
Hey, aren't you Buzz Lightyear?
But one stands for alternating current, which is constantly pulsating through the wire as it's going to whatever and doing all sorts of stuff. And DC, direct current, one pole of a circuit goes one way, does its thing in whatever it's doing, loads it out, comes back. Pretty simple. You gotta have a source of power.
Hey, McFly, you bojo! The cars don't work on water! Unless you've got power!
Which sources of power are, all over the place. So the reason we're not going to focus on AC, because we're not talking about AC 4400 locomotives. No. We're talking about DC. We're talking about the U-boats. The other General Electric locomotives that I don't like. Here. And no, seriously. AC is like electrical, what your house runs on, all that stuff. DC is what vehicles run on. They run on 12 volts. House is like 110 to 120, depending on who's going to tell you what. All the way up to like 240, sometimes more than that. But we're not going to get into electrical house stuff, 2-phase, 3-phase, coming from your power line. No, we're not going to talk about any of that today. We're just going to go over basic car wiring stuff. So 12 volts is what a battery produces. Some of your older model stuff, you're gonna get 8 volt, 6 volt systems. And that's when it comes into talking about amps and watts and why that's important and using it for measurements of electricity. Okay, so amps. It's the max current of electricity that something can move without exceeding its temperature. So most thing we know is you got a wire. And the amp is going to load up this wire to a point where it gets hot. We've all felt hot wires. But if it exceeds it, you're over amp. So that's how they kind of figure out ratings. So amp is a maximum current of electricity without exceeding its temperature. Thereabouts. Now watt is the energy consumed by something. So if you have a light bulb at the end of it, it might be 2 watts. It'll use 2 joule per second, which is basically 2 watts is what the bulb comes up to. Why it's called joules, I don't know. It's spelled weird, but it is what it is. So you got amps, which is what something can basically conduct or move, how much electricity can move through there without melting on the wire. And you got watts at how much something uses. Make sense? Sure. Now, why is that important? Well, we'll get into some of the safety devices now. So, as I just showed you there, you got safety devices, right? You got fuse A's. This one's a 15. This red one is a 10. And usually they're all color coded for however amps their thing. Red, 10. My little box here, even if we go to a mini style, which is probably more modern, it's red, 10 on the top. Of course, the blue one, if we pull the blue one up here in the mini, it's 15 as well. Green, I think, is 30. Yeah, 30. Wade style, the bigger one, the green ones are 30. So they all kind of color coordinate, if you didn't know that. Yellow, of course, that's 20. That's our favorite one. So, and what are they designed to do? What are they designed to do? Well, let's say you have a failure rating of this wire of 20 amps, right? Amps is how much current, the temperature stuff. Well, we put a 15 amp fuse in there. So what this will do is if it gets to the point of there's too many amps, 16, it's going to break the little thing, the little filament there in the fuse before it starts the wire on fire and melts it down and burns it to the ground. So it's a built-in safety feature. So all fuses for whatever circuit they're powering are just under what the maximum that a circuit can hold. And that's by design, because you don't want to burn down your thing. That's why it's very important when you're going through, you replace the fuses with what ones you pulled out of there, so don't be, you don't want to pull out a 20 amp fuse and replace it with a 30 amp fuse because it keeps blowing. You don't want to do that stuff, because there's a reason why it keeps blowing, and you got to figure it out. It's pretty simple. Okay. Forewarning, this video is going to be a lot of me just talking and showing examples and stuff, so if you don't want to learn about wiring, forewarning you now. Anyways, so put that back. So what do we need for a basic circuit? Let's talk about a basic circuit now. Well, we got to have something that's going to get powered. Light bulb. I can see you guys through it. Light bulb. Well, how do you power it? Well, light bulb's got to go into some kind of a socket, right? Boop, boop. So, how do you power the socket? Well, you power it with wires. Well, what powers the wires? You got to have battery, some kind of power source, something, right? Okay. Well, how do you control the light in case it blows up or there's drawing too many amps? You put an inline fuse in there, right? We all in our fuse box. Okay. Well, how do we turn the circuit on and off? Well, we got switches. So you got to switch. Click it on and off, on and off, on, off, right? Okay. That's it. Then you hook one side to the positive side of your battery and one side to the negative side to your battery. So let's build a simple circuit really quick. Just simple. So for a power source, I have this that is for model railroads to control a locomotive and make it go around some train tracks. I don't know. Turn it on. We should have volts. So we turn it on. Got a green light indicator on there now, you know, on, off. And it's going to put out 12 volts. Now we can go up to 20 volts with this thing. You know, it's got a little indicator on it. But now if we hook up over here where it says variable DC, that's going to represent our 12 volt battery that we can pull out of a car, but I'm just too lazy. So I have this jobber. So to build a simple circuit, you of course need a power supply, and you got to have something to power. Now for wiring, it's pretty simple. It's got some kind of a conductor inside of it, copper, aluminum, something inside of it. I don't know, whatever it might be. And it runs the electricity from point A to point B. It's simple. Now, to take care and cut these and make them how you want to and get them to the right length for building a circuit, you need a good set of tools. You got side cutters, which I've used these for frickin' years. This is all I ever used to use. That's what I grew up on, so that's what I'm very familiar with. It wasn't until, I don't know, 2 years ago, I actually bought this style of side cutter. And you can see it's got a little gauge on it. You can, you know, figure it out per wire and how you want to. And you just put it to where you want. And then you kind of just strip off the wire. And then you strip up the wire, right? So then you get yourself a good, you know, good connection. So tools are good. You can do the same thing with these side cutters. The only difference is they like to cut a lot. You gotta have a lot more muscle control, I guess, with when you're doing those. So to each is what it's own, depending on what you're doing. So now let's start building that circuit. So we got to hook to this power supply somehow, and it's got little like screws on it where we can open and close it. Well, what I'm gonna do really quick is I got these little fork looking connectors, and we're going to basically put those on the end of a couple wires, and we're going to build up a quick circuit. Now what I like to do is once I strip off a wire like that, you know, if you got too much, you can kind of just eyeball it to length to where you want it to, you know, get your other side of cutters there, and you can clip it. Once you get a nice little edge there, you know, slide it on. And once you slide it on, take your side cutters, crimp it down. Make sure you get a nice solid connection there and do the pull test. If I'm doing something on the vehicle, I'm not going to get into explaining how to solder, but I will solder, and then I'll end up using, I don't know what I did with it, heat shrink tubing, which heat shrink tubing like that, you would slide over beforehand, cover up what you want to cover up, heat it up, and there you go. It shrinks it down and basically makes it like a wire that you never had seen before. It was always like that. So we got one side of our circuit started. Got a set of alligator clips so we can be kind of universal with what we want to do here. And I'm just going to go ahead and slide our forky looking, you know, plugger doodabber onto our power supply. Like so. Kind of, can you tell I'm not left-handed and I'm trying to use my left hand to do stuff? Okay, so now I got another little alligator clippy thing. It's a little bit longer. It's okay. The end's kind of gross, brittle, but we'll work with it because I'm lazy and I don't feel like clipping it and stripping it right now. I'm going to take another forky doodabber one. We're going to slide it on there. Take these side cutters and we'll crimp our connection on there. You do have this flat edge on the bottom you can kind of crimp stuff with. You know, do something like this. It's in there. We can go like that and squish it. and it'll give us a flatter connection. Or these ones have a little bite jaw on the end of it. You can kind of give it some. So that's a good one. Tug test. It ain't going anywhere. So we'll go ahead and put that on the other side here. Okay. So we have positive, which is red. We have black, which is ground. Okay. All right. So now what are we going to do? Well, we got to power something. Well, let's power this light, because I have it sitting right there. So we'll connect one of the alligator clips to there, and then we'll connect the other one to here. Well, that's a circuit. So now that we got our circuit on, how do you control it? Turn it on and off. Switch. Switch will break it, break the circuit, break the circuit. So now let's build that into our circuit. So take our power off, our positive, and some of these switches, they have like instructions on them. So positive is going to be on this side, and the one side over here is the ground, and then in the middle is accessory, or what we're going to power. So I'm going to take this power up accessory to there. We'll take another wire, because we got to, we went from, changing our source of load to here. We'll just carefully put it onto there, and we'll connect it to our load. And when we flip the switch on, it's supposed to, oh, silly me, because I got to put it in the middle one. So we put it in the middle there, like so. Now we got our switch, because I hooked it up wrong. See, even I do stuff wrong. So now we got a circuit. That's a circuit with a switch. So the other one's actually just a ground to, there's a light inside the switch that comes on and off. That's what that's for. But so yeah, pretty simple, right? Yeah. So we got that on. Well, what happens if we want to put some protection on it, because we might drop a screwdriver and short it out and then start a fire, because that wouldn't be good. Well, that's when we got to go to our fuse. We got to put some type of a fuse. Some type of a fuse setup into what we're doing here. So, do we want to protect the switch? Maybe. Do we want to protect the light? Maybe. For our sake, we'll protect the switch and the light. So, that clip goes on to our one side of our fuse A, and the other side goes on that one. And look, once we clipped it on there, now we have a fully protected circuit with a fuse that's on a switch. You getting the gist of it yet? We're just completing loops, and we're putting brakes in it where we need to. Okay. So, what happens when you want this light to do something other than just stay steady on? You got to add another device. These are flashers. This one is for your regular flashers, and this one is for your hazard. It's got little stripes on it. Some are green, some are single. I don't know. There's a couple different types. Got these electronic ones that I use on stuff like the Impala electronic flasher. This one is actually from the Trailblazer, and it's square. They come in all sorts of different shapes and sizes, but they all do the same thing. On the inside of them, there's a little filament, and it makes a connection. And as soon as that little filament heats up, it goes whoop and disconnects, and then cools down and drops back down and connects. And that is your flashing that you hear inside of the flasher. So let's go ahead and add a flasher now to our light and see if we can get it to blink. We'll disconnect our power from our switch, and we'll hook it to the flasher. Another wire. Do I got another wire? Yes. Another wire laying around. We'll have this come from our switch now. And we'll connect it to our flasher. The theory is this should start flashing if there's enough load on it. What happened? Oh. Whoop. Whoop. Our flasher is flashing. So we got enough load on it with that one. Typically, one light bulb won't be enough load on the flasher to heat up the element inside there and make it happen. So sometimes, if you watch, we put another light on there, that thing should pick up in speed. Because now you're putting more load on there and you're heating it up quicker and cooling it down quicker and making it actually do what it needs to do. So when you have a light bulb that's out in your flasher circuit, the flasher circuit has enough power going through it, just enough where all the bulbs are reading just right to power that flasher to the speed that it needs to flash. So if you get a bulb that burns out, that's why you either have one stuck on or a slow flash. See, we're already diagnosing stuff as we're going through. Let's do it again, because that was kind of fun. Wow. Okay. It's circuitry. It's pretty simple. So now what do we want to do? Well, I don't know. Maybe this bulb has got to have a dual feature on it, kind of like this bulb right here. If you take a look at it, it's a dual filament 11. Well, this is actually a 2057, and 1157s will be clear, but they got two filaments on it. And on the bottom, it's got two spots for connection. Now what it does is it shares the same ground on the outside. Here's a socket, so this wire will be the ground, but then the two wires coming up go up to the bulb. Why is that? Well, because there's two circuits there. So you have one circuit that is on your middle one, which will be your flasher, flashing like so, and then the other one for that bulb over here will be your parking lights. So your parking light's on. So you'll see the light will stay on when you got your headlights on, but you also have your flashing going on. So that's a combined circuit that they have going on with your parking light. Why am I telling you all this? Because it all can tie in and make one circuit, or it can be two circuits, or it can be three circuits, it can be four, or it can be a computer, and it can be like 500 million thousand of them, and you just got to sit there and figure out and go like, I need to figure out which circuit I'm working on, right? Right. Okay. Turn off our clicky clacky there, because we got a switch, we can do that, right? Okay. So let's get into figuring out this circuit, right? We have a problem. Houston, we have a problem. We don't know what our problem is. You probably do, because I just made it happen. But if we go to turn that on, we ain't getting nothing going on. And you're sitting there scratching your head. Why? What am I doing here? I'm telling you, you gotta start with the basics. Always just the basics. I've surprised the shit out of myself. Basic stuff. Look at your fuses. Are they blown or not? Check the bulbs. Is it blown? Is it not? Okay. Third thing I always check is usually a ground or some kind of a loose connection. Typically a ground, because you're outside and stuff rusts. You know, it'll rust because it's exposed to the ground. Or whatever. Just start with your basic stuff. And then if you can't figure it out from there, you break out your other tool that you got. If you don't have one of these, this is $6 at Harbor Freight, and I've had this for like 4 years now. I do have a nice fancy one that you've probably seen all the other YouTubers use, and like, oh my gosh, that thing is so complex. I haven't even opened that thing yet, because I'm still using my cheap $6 one from Harbor Freight. So, with that, I hope you guys got some useful information. I'm going to put a video in here that I had from Angus, and I kind of went through, did some diagnostic stuff, and found out that I had a blown fuse. So, hope you enjoy that. Well, hey, welcome back. Yeah. Well, what had happened was, fired it up, left to go to work this morning, and lost all power. Now I'm trying to figure it out. So, started. I was early in the morning, so I unhooked the battery. And I just, hooked it back up. Decided to pull out the good old, meters of multi. Start with the simple things. And for sure, I got, 12.8, 13. I got bolts on that. So it's not there. After I confirm that, hook those back up, confirm my ground. That's positive. Grounded it out on the body. We're getting the same voltage, no voltage loss. So I know my cables are good. So I moved over to the fuse box here and got a main cable coming in here. And the power goes through all these, and then right here goes to my box down there to the truck, the original factory stuff. All underneath it's got the fuel pump and all that stuff, but you see my wipers are up because they were going, and I just stopped dead track. And headlights, they were on. When I say I had no power, I had no power. So getting my multimeter out, I started checking the main wire that comes in. Got the V's right here too, so that's good. So then I started seeing if I got them on these fuses. This one, on the one side I get 12 something, the other side I get like 0.6. That ain't right. And all these other ones are dead. Yeah, we ended up blowing a fuse, and let me show you how to test for that. So you can see our multimeter is at 0. We're grounded out. These top of these fuses have those little tiny bars on them. And what you do is you take your multimeter, your other side, and you push it right on top. And if you got power, you got power. So what happens when we switch sides? Nothing. Uh-oh. That's probably a bad fuse. So if you're unsure if it's a bad fuse, you can continue to use your multimeter and figure it out from here. And that's simply pull it out. If you can't look and see that it's blown, well, you do a continuity test. Change it over to the horseshoe mode. So when you get continuity, you touch them two together and they do that. Well, you take your two prongers and you do this, and if that's a good fuse, you'll get the same reaction there. Got bugs killing me. So when we put them together like so, we got nothing. So that tells me that fuse is blown, even though I guess if you look at it hard you can see, but she's popped. So just had quite the load on it. These giant fuses, I apparently don't have any floating around. Next smallest one I got is in here, is a 40. I think that'll work. I'm sure it'll work. The question is why? Whenever you blow a fuse like this, you gotta ask yourself why. And I know 30 amps running the engine, running the computer, running the wires, or the motor, running the headlights, running the wiper, and I had the blower motor on too. That's a lot of amps to be drawn through this 30 amp fuse, so it's probably going to be fine. So I'm just going to send it with a 40 because that's what's there if it works. Because I think those other ones are kind of just like there. If not, we'll go buy one and call it a day. But that's how you check your fuses. That's how you check stuff out. Just go with the easy stuff first. I mean, I was like, oh, panic attack, just all of a sudden died. Why? It's a fuse. Frickin' fuse. Well, let's double check and make sure it is frickin' fuse. Okay, I got that in there. let's just pull the headlights out. I can already see my lights are coming on. Oh yeah, we got the headlights. Does it start? I don't know, maybe, should. Hopefully it doesn't blow it again. Yeah, see, I had everything going. So again, with that, just make sure to look at the simple things first. Don't flip out. It is what it is. Angus is back up and running. I'm gonna have a beer. Cheers. Yeah, Oktoberfest season. Thanks everyone for watching. Please like, subscribe, share, comment below. Tell me what you guys do differently when you run into trouble like that. Just out of a whim. We'll see you in the next one.